Hello everyone, and thanks for being here after lunch. I know it's always a difficult moment of the day, but thanks. I'll try to be fun. Usually that happens, but I cannot guarantee it. Okay, so in this talk we're going to see how we could help you make your app more adaptive, starting from a phone app and a TV app. Okay? Yes? Yes. Perfect. That's the kind of excitement I need. Okay, so first, I'm pretty sure that everyone is familiar with Androidify. So building an app that runs flawlessly on phones is fairly easy nowadays, especially with Jetpack Compose and all the new tools that we have. But let's check also the other end of the spectrum with TV apps. With the recent introduction of Compose for TV, also creating apps for TV is fairly simple. But how can we get from one to the other? How can we make our app run everywhere Android runs? That's a tough question, right? Yeah. So let's take a look to how Androidify works on a phone. So this is the main screen. And here we can already see a very interesting piece, which is the carousel that shows the animated logo, and a video that showcases how the app works. And when you tap on Let's Go, you see this amazing animation that brings you to the main UI, which is the photo picker and the prompt, which we can, let's say, well, it's a tabbed UI after all, right? Then, when you tap on Bot Color, you raise a bottom sheet. And this is actually quite important, because the bottom sheet is very, very peculiar when it comes to make your app more adaptive. And then, when you press Transform, you can share the result. And you're presented now with this screen, which is a very peculiar UI that runs beautifully on a phone. But how would it look on other displays? Who knows? Perhaps I do. Perhaps I don't. Who knows? So, to recap, there are some things that we can leverage to make the app more adaptive. First, there was the carousel. Second, there was the bottom sheet. And then the exporting screen. Those are the three key elements that we can leverage to make our app more adaptive in this specific scenario. Okay? So there is a lot that we can use there. When it comes to TV, things are slightly different. Because the first thing that we notice is that the navigation is on the top. Here we have two levels of navigation. The first one is the main navigation, and the second one is a definition, let's say a clarification of what's in there. So you press the first one, you get the second navigation, you press the second one on the top, and it changes, and so on. And that's amazing for TVs, because with the remote, using up and down and the center button is fairly easy. Of course, TV has its own guidelines, like an uncluttered UI, which needs to be clear, and fewer elements. So there's something to do there. Then, as we mentioned earlier, we have Compose for TV, which makes our life much easier compared to the old leanback. Compose for TV is another implementation of the material components, and it's a library that we can leverage to bring our app to a more adaptive world. Also, we need to retain the state, which have been always something that we know about phones, right? Especially when we talked about unlocking the orientation, that was a huge problem. Luckily, we have all that experience, because retaining the state is something that we will need to do as well when we port our app from TV to everything else. And of course, we need to adapt the layouts, because this is great for TVs, but probably we can do something for the other devices. OK, so now let's see that all together. OK, because, well, Android runs on a variety of devices with different form factors and everything. So let's start with our TV, which, well, I placed on that side of the spectrum because that's how I decided to do it. And then there is phones at the exact opposite. Why are they at the exact opposite? Because they have very different interactions, information densities, and UI. But how can we make them run flawlessly everywhere, from phones to TVs? And also, we need to take into account that we don't only have those two devices, but we also have XR, we have foldables and tablets, and laptops. But also, we now also have connected displays, which have been recently introduced in Android. So that's a lot of different surfaces that we have to cover. So let's take a look at what we can use to actually achieve our goal. First of all, both the apps have been written with Jetpack Compose. So that's something that we're going to leverage. Then we can use the navigation suite scaffold to make our life easier when it comes to switching navigation between different size, let's say, window sizes. This is a library which comes from the Material Tree adaptive sets of libraries that you can easily implement in your app. But we're going to see how in a few minutes. Then, of course, there are window size classes. Because, well, we are all familiar with that, right? Yeah, nobody said yes. So luckily, I have another explanation of window size class coming. Great. And something that well, is often overlooked upon, but it's very important, which are previews. And those can change the way you develop and the speed at which you develop. But you don't have to take my word for that. But we'll have samples that hopefully demonstrates what I'm saying. And then there will be some other smaller tricks that we can implement to make our life, well, our app, even better. OK? Are we all ready? Great. So, of course, we're going to start from window size class. We're all familiar with them, but I'm going to explain them again, because I like explaining them. Who knows me knows that. So, the whole idea is that we want to decouple the size of the window in which your app runs in from the screen size. Because on phones, they might roughly be the same, but that's not always the case on any other surface, or if they just run on split screen. OK? We need a consistent way to display our app so that regardless of the device, it will always behave in the same way given the same space constraints. So if the app is in a small window, it should always behave in the same way. It doesn't matter where it runs. What matters is the size of the window. And of course, they work with both width and height. So you can fine-tune your app based on the amount of space you have at your disposal. And based on your app, you can either check them both or just check one of them based on what you need. So with the recent introduction of Window Manager 1.5, we also introduced two new more breakpoints. So earlier, we only have compact, medium, and expanded. Now, we also have the large and extra large breakpoints for width. These two new categories are key to cover even more situations. Imagine that, again, your app is running on a huge 4K display, which has a resolution of 4,000 by whatever. Expanded is probably not enough. So that's why we have large and extra large. But how do we do them? Because we didn't see any code yet, right? Well, luckily, we have some code. So first, your app needs to figure out in which of these buckets is actually fitting. The Android framework makes it quite easy to understand that by using the window matrix calculator. Then, if you use the window size class before, and I hope that you all did, you will notice that now the new breakpoints have been added to the V2 set, which is a superset of the breakpoint V1, let's say. So if you're using the window size class today, what you need to change is just the version, and you'll get the new breakpoints. And then, with a simple if, you just check in which of the buckets your app is running. This is all the code you need. OK? Super simple, right? But of course, we also brought these new breakpoints to the Material Tree Adaptive Library, which is now in release candidate. The new version 1.2.0, super complicated to say, actually only leverage the same function that you're used to. And the only change that you need to make in order to support the new breakpoints is adding a parameter, which I'm not reading because it's incredibly long, but it's basically a flag. It's disabled by default, so whenever you're ready, you just need to flip it to true, and you get support for all the new size classes. And that's basically it. OK? Super simple, right? Do you want me to explain them again? No. Super simple, right? Yes. Perfect. You see? OK. Now let's dive into an essential UI consideration, how we display items. Because a lot of apps make a heavy use of lists, whether they are horizontal or vertical, right? Just think about 10 apps, and I'm fairly sure that in at least 9 of them, you'll find lists, right? Yeah, perfect. I know you're all asleep. I'm trying to wake you up. I'm trying. So on TV, carousels are fantastic because you're sitting on your couch, and you can simply press the side button on your remote. Everything works flawlessly. Even if you have hundreds of titles, that's going to work, right? Probably just a little bit of pain on your thumb, but that's fine. I mean, we can all endure that. But when it comes to phones, well, we are more used to scroll vertically. We can scroll horizontally because, I mean, we have thumbs that can do that movement, but we are more used to scroll vertically. So how can we make sure that the same layout can cover them both? Well, this is where something like the feed layout comes in handy. It's not the only solution, but it's an example. Why the feed layout? Because the feed layout offers a huge amount of freedom when it comes to customize. So imagine that you implement it with a grid. The easiest way to make it work for both vertical, horizontal, and more grid kind of layouts is changing the amount of rows and columns. And together with the window size class, it's actually fairly easy. So how do we do that? So depending on the window size class that we checked earlier, we can change the number of columns so that when your app is at least in a large window size class, you can show 3 columns, for instance. When it's in a smaller, medium, and expanded one, it can be 2 columns, or revert to 1 on candy bar fonts. One thing to note is that when you're checking for window size class, you should always put them in order from the biggest to the smallest. That's because internally, it's a bigger or equal than. So basically, if you are in a large and you put the second check before, it's bigger, yes, so it's going to pass. So the only way to get them right is put them in order. OK, so once you have that, you need one small piece, which is actually telling the grid that you want a fixed number of columns. And that works flawlessly if you have a very precise design with very precise breakpoints, and everything fits together quite nicely. On the other way around, you could also just say, I don't really care about the exact number of columns. I just need them to adapt and be of at least 20 dps, let's say. And you do that by using the grid cell adaptive method. So we have the two ways of implementing the same way, based on if you need a specific number of columns or if you just need the space. In the second case, of course, the grid will calculate how much columns they can fit based on the size of the window size class and the size of, well, the minimum size that you need. OK, now let's talk about navigation. So we already said that on TV, the navigation is usually at the top, and it's very comfy. Well, but while that makes sense when you are on a TV, it doesn't necessarily make sense on other devices, like phones, tablets, or foldables. So how do you do that? Well, we can solve that by using the navigation suite scaffold, as we already mentioned. But it's not enough in this case, because we need to know if the device actually is a TV-like device. So what we want to do is actually checking if we need to use a top navigation that we can implement, or we can use the navigation suite scaffold by wrapping your scaffold if you already have one, or migrating to the navigation suite scaffold if you don't have one. The navigation suite scaffold is interesting because it will automatically switch your navigation based on the window size class. You don't need to check anything. You simply pass in the items, and based on how much space you have, it will put the navbar at the bottom or the navrail at the side, based on how much space you have. So it's actually fairly useful. And the implementation is actually easy. And for being more future-proof, it works already with the XR components. So you just wrap them into the overrides, and you get nice features like the orbiter. So with one scaffold, we cover already all the spectrum. So let's see in detail how we can implement the navigation suite scaffold. The first thing you want to do is defining your screens. So if you were this morning at Don's talk, those are not routes. Those are just the entries on the list that you, well, on the component that you'll see. So in here, we just have the name, icons, and how they should behave when you tap on them. Then inside, you get the padding, because, of course, it takes up some space. And you can place your composables. Of course, you also need to remember which one is selected, because you might want to change how it appears, or this kind of stuff. And you do that inside the item that we declared earlier. And now let's switch gears to previews. So previews are usually overlooked upon, but they are really a game changer, because if you want to show, well, to see what you're developing on a huge variety of devices, well, previews can come in very handy. But let's see how we can help them, because while there are the preview screen sizes that cover all these scenarios, they might not actually fit your use case. For instance, in Androidify, we had some specific composables that would only run on specific screen sizes. Sorry, window sizes. You see, I got that wrong. So these previous screen sizes would not really fit because we would have a huge amount of previews that weren't needed. So instead, we decided to use our own previews. And the important part is that we could pass in all the parameters that we need. In this case, we were checking something that supported tabletop mode. And doing that is actually a bit verbose, but fairly simple, because you create a data class with your parameters, create a provider, and pass the parameter with an annotation. In this way, you always have all the parameters that you need, and you can change your preview fairly easy when you declare it. But also, we had some animations with the shared element transition. So we needed to wrap them into a composition local provider so that we could actually see the preview. In this way, you not only can pass in the context for the animation, but you can pass in any fake data or anything that you need to make sure that you see your previews in the way that actually helps you. OK, but of course, we also want to make sure that our app feels natural on other environments, like desktop, because that's what happens when you connect an Android device to an external monitor. A desktop window in environment replaces the classic full-screen experience that we are all used to, and we get some nice tricks. So the first thing that comes to mind when you see this is the caption bar, the top bar, where you see here the name of the app and the close and the resize button. Okay, that's the first thing that comes to mind. But there is also something that is fairly common for desktop use. And it's often overlooked when it comes to mobile, which is drag and drop. Okay. How many of you already implemented drag and drop? I see at least 3 hands raised. Great, so I can explain something else. Perfect. So on desktop, we are all used to dragging and dropping files, right? Because, well, we did that at least once in our lifetime. But on mobile, that's a bit different. We see them more with bigger devices, but, well, the implementation is anyway fairly easy. Let's see how it works. So first things, we need to set up a filter for our drop action. This comes straight from Androidify. So if you go on GitHub, that's what you're going to find. What do we do here is checking what kind of file the users are sharing with us. So since Androidify only works with pictures, we wanted to make sure that anything that came in was actually a picture. So we check the MIME type of the drag and drop event, and we check if it is, in fact, an image. And only then we allow the user to drop the image in our app. Once the drag and drop action is accepted with the method that we just saw, we need to define our app will react. And we use the drag and drop target interface. This interface has a few very interesting methods, which can help us define our UI and our behavior. So the unstarted and unended are 2 methods that are fired whenever the user starts the dragging operation or raises the finger. This can be incredibly useful to change our UI so that we can show a message in our drop-in area or just changing the background. And then we have the on-drop event, which is actually the crucial part of our implementation. Because while the UI is very important, this is where all the logic for handling the image takes place. And there are a few caveats to take into account. So first, we need to check if we have the permission to accept the drop. This is not an explicit permission that the user will see. It's managed by the system. So if you're doing that outside an activity, you actually need the activity to run it. What you do there is requesting the permission. And if the permission is not null, you do all your things. But remember that this permission is temporary. So as soon as you release the permission, you won't have access to the data anymore. So how do we do that? How we make sure that we actually can use the image? Well, first, we get the clip data, well, the URI in this case, from our event. Then we decode the image into a stream, and we save that in the local cache file. Why do we do that? Because, again, as soon as we release the permission, we are going to lose access to the image. So accessing it from our cache is the only way. And then, once we have our cache file, we can simply say, OK, now manage it, because well, we might display it, or well, rather than display, I don't really know what else we could do. But we need to display in our UI, and then we release the permission. Again, as soon as we release the permission, we won't have access to the image. So it's important that everything is done between the permission request and the permission release. And the last step is actually gluing everything together, because so far we only saw how the drag and drop will actually work. So how do you do that inside your composables? Well, you use the drag and drop target modifier. It accepts mainly two parameters: the filter function, which is our should start drag and drop method, in which we'll put the filter that we defined. So in this case, it will return true only if the dropped file is an image. And then, for the target, we'll invoke our callback, which is what we just created. So the interface with the unstarted, unended, and onDrop. OK? And that's all of it. If you want to see all the code, is inside the Androidify repo. OK, so we mentioned the caption bar earlier, but I'm not covering these today. We have another talk tomorrow, also because we are running out of time, so it will take more time. So make sure to come to Francesco's talk tomorrow at noon. And if you're curious to see all the code that we used to make these changes in Jetstream and Androidify, make sure to check them out on GitHub. And this is actually how Jetstream is now running across all the surfaces. So if you are curious to see how we made that happen, that is the link. And I believe I'm done. Thank you.